Welcome to our O level math students. Here is a very important update for 2025-2027 program. Reciprocal functions have now been included. Here are four examples to understand them and to graph them accurately. Let's enjoy this journey. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we are going to look into some important updates in O level mathematics. This is for 2025 and 2027. This video is specially made for our new students who will be getting into this program at grade 10, grade 11 level. Well, O level is getting ready for A level maths. It is equivalent to UK GCSE or IGCSE. Now, I have listed the major topics for O level mathematics. The major topics, as usual, have numbers, number systems, that is, algebra and graph, coordinate geometry, mensuration, trigonometry, transformations and vectors, reciprocal and rational functions, exponential functions, probability and statistics, and then we'll have some sample test problems. Well, in this update, we are mainly going to discuss two new topics which have been added this year. So they are reciprocal and rational functions and exponential functions. Well, I have many videos from past test papers where you can actually understand what type of questions are exactly asked for O level mathematics. So we have by the name GCSE also. But in this video, I am going to explain the new update on the particular level for our new students registering for 2025 to 2027. So we look into what is a reciprocal function and take up some transformations based on this. And in the next video, I'll discuss in details the exponential functions, which is an addition for this particular curriculum. So let's begin with talking about reciprocal functions straight away. So reciprocal functions, I've shown a graph here for a reciprocal function. We'll look into the domain of this function, range of the function, asymptotes, increasing, decreasing intervals. We'll find the end behavior and look into transformed reciprocal functions and then graph them. To give you a clear cut idea, we are going to take four examples. As listed here, we'll begin with example 1, which is y equals to 1 over x. We also call it parent reciprocal function, right? Reciprocal, as you understand, if I have a function y equals to x, then what is the reciprocal of this? Then y equals to 1 over x becomes the reciprocal function. And in function notation, we are going to write this as f of x equals to 1 over x, right? So when I write f of x equals to 1 over x, it is the same as y equals to 1 over x, but in function notation. Perfect. Now we have shown a graph here of y equals to 1 over x along with the graph of y equals to x, which we are going to discuss soon. In example 2, we'll consider transformations of this particular function minus 2 over x, and then we'll take up y equals to 1 over x plus 1, which is horizontal translation of one unit to the left, and then we have y equals to 1 over x plus 1 plus 2, right? So we have transform functions to look into. So let's begin with the characteristics of reciprocal functions. So let's see what is reciprocal, right? So let's begin with the number system itself so that the concept is absolutely clear to you. So what am I going to do here is I'll take up some values of x, right? So if I take a value of x as, let us say, 1, right? So let me write down number here, 1. So if I have x as 1, then what is the value of 1 over x? Well, reciprocal of 1, as you know, is 1 itself. So it is the same number, right? So as you can see in this graph, we have a point right there, correct? So this point on the reciprocal function, which is shown in red, this is the graph of x, right? And that red graph is y equals to 1 over x. So we see we have exactly same point and the coordinates are 1, 1, correct? Now, if I take a value which is minus 1, right? So let's take minus 1. Reciprocal of minus 1 is going to be negative 1. And that gives us the other point here, which is common between the straight line y equals to x and its reciprocal function minus 1 for 1 over x, right? So we have this common point as you can see here. So that is kind of invariant. So we call this as invariant. It is common between x and 1 over x. You see that? So another new term for you to understand, which will be soon taken up when you talk about transformation of any function. Now, in reciprocal function, the invariant points are 1, 1 and minus 1, minus 1. Perfect? Since you can see that the reciprocals are same, right? Now, let's take another point which is 2 and minus 2, right? So, if I take minus 2, reciprocal will be minus half, right? And for 2, it is going to be half. What you really see is that for a bigger number which is greater than 1, reciprocal is very small, is smaller, right? If I take another value, let's say 10, then its reciprocal will be 1 over 10, means zero point 0.1, very, very small, correct? So you see that as the number increases, the reciprocal of that actually approaches 0. It is very, very close to 0, right? So, and also what you notice here is that reciprocal of negative numbers is negative and reciprocal of positive numbers is positive. Well, that gives you the idea that, we have the graph in either quadrant 1, right, or in quadrant 3, right? Makes sense for a reciprocal function. Because for negative, the reciprocal is negative. For positive, the reciprocal is positive. So the values here, as you know, will be for both x and y will be negative, negative, right? And here they will be both positive, positive. Makes sense. So the graph is has a symmetry about the origin and it is placed in quadrant 1 and in quadrant 3. Makes sense, right? Now, important thing here is if x is equal to 0, you will see that we wrote here that the function f of x, which is in the denominator, cannot be 0. If I'm talking about x, can I divide by x? We cannot, right? So at this point, we have a vertical asymptote. So at x equals to 0, you see that graph approaches infinitely large value, right? But it will never be there. So what we notice here is that when x approaches 0, then 1 over x approaches infinitely large value. Now, obviously, if you are approaching 0 from the positive side, you go towards positive infinity. And if you approach 0 from the negative side, then 1 over x will be approaching negative infinity. Makes sense, right? As you can see here, correct? So you see, it does approach infinitely large value. However, if you are approaching 0 from the left side, then you approach negative infinity. And this is called a vertical asymptote whose equation is, well, the equation is x equals to 0. You see that? So this is a very important part of any reciprocal function. As you can see here, when the denominator approaches 0, the function approaches infinitely large value. Now, what happens when you approach infinitely large value? So, when x approaches infinity, you're dividing by infinity, right? So, in that case, 1 over x approaches 0. And definitely, if you are approaching towards the positive side, you are approaching 0 from the positive side. You see that? And here you can see when x approaches negative infinity, in that case, 1 over x approaches 0 but from below the x-axis. So you can see how it approaches, and this is called horizontal asymptote, right? So horizontal asymptote is y equals to 0 for a reciprocal function as shown here. Makes sense? So with that, we have summarized the characteristics of a reciprocal function. Now let's specifically look into the graph of the function y equals to 1 over x, which is reciprocal of x, right? So we have a graph here in blue for y equals to x, and the red graph is y equals to 1 over x. So 1 over x is the reciprocal of x, right? So 1 over x is reciprocal of x, correct? Right. Now, here you can clearly see all the points which we discussed. Let's begin with the vertical asymptote. Vertical asymptote is a restriction on the domain of the function. You see, x is not equal to 0, right? So, what is happening at vertical asymptote is that when x approaches 0, from the left side, in that case, y approaches negative infinity, and when x approaches 0, from the positive side, means right hand side, in that case, y approaches positive infinity. And the vertical asymptote here is x equals to 0. So x equals to 0 is the vertical asymptote. A very, very important characteristic of the parent reciprocal function 1 over x. Makes sense, right? So this is the line which is x equals to 0, the vertical line, and it is called vertical asymptote. Makes sense? Now, you see, x equals to 0 is not in the domain. So, from here, we can say very clearly that the domain of the function is x belongs to a set of real numbers. However, x is not equal to 0. Makes sense, right? Now, let's talk about what happens when we are approaching infinitely large value. So, when x approaches negative infinity, we know that y approaches 0 from positive side, oh sorry, negative side, right? Right, negative, negative. And when x approaches positive infinity, y approaches 0 from the positive side. Now, this is called horizontal asymptote, right? So, we have a horizontal asymptote, which is y equals to 0. This horizontal line, y equals to 0, it is approached but never reached by the reciprocal function. Hope that is absolutely clear. Now, vertical asymptote and horizontal asymptote actually are most important when we sketch the graph of a rational function. So, normally, these are the first things to be sketched. We'll see it later with our examples. Perfect. Now, that also gives you that a restriction on y values. So, we can now say that the range of the function is what? Y can have all real values, but y cannot be equal to 0. Makes sense? Right. So we have talked about domain and range. We have a restriction. In domain, 0 is not included. In range, 0 is not included. That means this point origin is out of bound for the given function. Makes sense, right? Okay, great. Now let's talk about the increasing and decreasing behavior. Now, what is increasing interval? Well, increasing interval is when you look at the function from left to right, right? Check from left to right. So when you check from left to right, you see the value f of x, the y value decreases, right? So it is always decreasing, you see. So it is never increasing, right? Increasing, never, correct? But it is always decreasing, right? So the decreasing interval is from minus infinity to 0. 0 is not in the domain, right? And from 0 to infinity, both not included, of course. So it is always decreasing in its own domain. You see that? So that is how we can describe increasing and decreasing behavior of this particular function. Another thing which you notice is that it is symmetric about the origin. We call this as odd symmetry. It is symmetric about origin. You can say that f of minus x is equals to negative f of x, right? That is the definition of odd symmetry. And there is definitely a point, right? You can see, which is a mirror image from point O on this particular function. So it has an odd symmetry. So we have learned so far that in the domain we have a restriction x is not equal to 0. In the range we have a restriction y is not equal to 0. We have a vertical asymptote x equals to 0, horizontal asymptote which is y equals to 0, right? The function is always decreasing in its domain, which does not include x equals to 0. Perfect. So, with that, we have understood the characteristics of 1 over x, a reciprocal parent function. I hope so far everything is absolutely clear. Well, you can always join my classes by sending email to globalmathinstitute and gmail.com. Our students are doing excellent. Perfect. Now let's move on and see second example where we are jumping into other parts of this particular unit which relates our new function, reciprocal function, with many other things. So we are now looking into vertical transformations. So in vertical transformations, the graph is being either reflected or it is being vertically stretched or vertically translated. Now here what is happening here is that we have a function y equals to minus 2 over x. So there are two types of transformations when we compare it to the function parent function 1 over x, correct? When you do this comparison as compared to 1 over x, what is happening? So 1, this minus indicates it is reflected on x-axis. And this value 2 indicates it is vertically stretched by a factor of, it is important to write factor, means multiplied by a factor of 2. That basically means that on x 1 over x, if we have a point xy, then its image will change. X values will not change in this case since these transformations are vertical transformations, right? So minus 2 times y will be the value, correct? So that is how it is going to be. So that really means what? As far as the asymptotes are concerned, the restriction is still x equals to 0, right? So x equals to 0 means we have a vertical asymptote which is x equals to 0, right? And we have a horizontal asymptote which is y equals to 0 for this particular function, right? So we have vertical asymptote x equals to 0, horizontal asymptote y equals to 0. Correct. So we got two important parameters. Now what happens to the points, right? So let's consider the uh, transformations, right? So what happens is that the point which was, so the key points which we always consider is 1 1 and minus 1, correct? So if I take, let's say, minus 1 on the graph, then it will change to what? Well, at minus 1, instead of minus 1, we'll have 2, right? The y value, correct? And for 1, 1, the transformation will be for x value of 1, we have minus 2, correct? So at 1, we have minus 2, and at minus 1, we have plus 2. You get the idea. So this is the vertical stretch, right? So instead of the point being here, here, it gets reflected, correct? So let me just show you lightly that the graph of 1 over x will be something like this, right? So I'm drawing graph of 1 over x, correct? As we have seen earlier. So what has happened is that this particular point has shifted to reflected on the x-axis and then multiplied by it. You see that? So it is vertically stretched and reflected. So we have a graph like this. Do you see that? So it goes through this particular point, and that is how it is. So the graph, which was earlier in quadrant 1 and 3, now is in quadrant 2 and 4. Correct? Makes sense. And the function is always increasing. Does make sense to you, right? So that is a major change of this transformation when we are trying to sketch the graph of minus 2 over x. I hope it is clear, right? Now let's take up the next example where we are going to consider a shift in the horizontal direction. So we have a function, example 3, which is 1 over x plus 1. As you can see, that the restriction now is that x is not equal to minus 1. So the vertical asymptote now is at minus 1. You get the idea? The horizontal asymptote still is at, because there is no vertical translation, is at y equals to 0. So that is one thing. Second, as far as the points are concerned, the xy points will now change. The x values will shift one step to left and y will remain same. So if I consider minus 1 minus 1, then the transformation will be minus 2 minus 1, right? And for 1 1, it will be, so 1 will come to 0, right? And 1. So that is how it is. So we have this, so the point which we're talking about now shifts, right? So at 1, we have 1, right? Let me sketch it in red now. So at 1, we have the point, sorry, uh, at minus 2 we have 1, so minus 2 we have minus 1, so that is the point, correct? And the other one is at 0 1. Do you see that? So the whole graph has been shifted 1 unit to left, correct? So shift 1 unit to the left. So the transformation basically is shift 1 unit left. Do you see that? So domain range remains the same. Sorry, not the domain, but the range. And you can see that the graph is always decreasing and the vertical asymptote shifted left by 1 unit. The whole graph shifts left by 1 unit. Perfect. So let's move on to the next transformation which we have. So I changed this equation to y equals to 1 over x minus 1 plus 2, right? So now can you tell me what kind of transformation is taking place now? So as you can see, x is not equal to plus 1, right? So we have a vertical asymptote which shifted from x equals to 0 to the right by 1 unit, which is x equals to 1, correct? So translate 1 unit right, correct? And that plus 2 means 2 units up, correct? So in vector notation, we can also show this translation as x value is 1 and y is 2, correct? So that is the kind of transformation which takes place. And some of you will be doing vector notation, and that's a way to show this translation uh, in this particular case, right? So there are both transformations, both in translated horizontally by 1 unit and vertically by 2 units, right? So 2 units up. So let me write down y equals to 2 for the horizontal asymptote, correct? As you can very clearly see, and there are no reflections, so still our graph will be going through 1 unit above this. Let me now sketch it in a different ink. Graph will look like this. Does make sense to you, right? So what you see is that the xy values on the parent function will not change. X values will be added by 1 and y values will be added by 2. And that is why the point which was 1 is minus 1 and 1 and 1, which are important points to consider always for sketching the graph. Now, as you can see, is at 0, and when you add 2 to this, it becomes 1, correct? And then to 1, it becomes 2 and 3. Makes sense, right? So this is our point 2, 3, and that's the point which is 0, 1. Makes sense? So that is how you are going to sketch the graph. Since there is no reflection, the graph is still decreasing in its domain. So with that, I hope you have understood clearly about this new addition, which is we're talking about the reciprocal function. I've added all these graphs here, club them together for your reference. You see how the graphs will get, transformed. So that is transformation of reciprocal function. I hope with this video you got some good idea about what is this new change and how do we deal with it. Well, to get into details of reciprocal and rational functions, you may join my classes by sending an email on globalmathinstitute@gmail.com. In our playlist, which is already there for advanced level GCSE, where this was already there, right? You can see many videos on this particular topic. Well, thanks a lot for your time and all the best.